Alright, so this diagram looks a little bit different, but that's because with hyperbolas we use a double cone. And with the double cone we are slicing straight through it to get this shape of hyperbola. And these are graphed on the same set of coordinate axes. This is in your textbook on page 428. But again, we're only going to be working with hyperbola that have a center at 0, 0. Some nice things. The way we find our foci is the same, and the sum of focal radii is the same. However, we are going to look at equations of asymptotes, because that's actually very important when we're dealing with hyperbolas, is because they approach specific lines but never touch them. And those lines help define the hyperbola. So on the first hyperbola that you see, the larger value is first. This is what I would call I'd call that like an up and down parabola, only because, or hyperbola, because it looks like two different parabolas. The next one, where y squared is first, is going to be more of a side-to-side hyperbola. But again, we still need to be able to figure out the asymptotes of the parabola, of the hyperbola. I'm sorry, I'm getting tongue-tied. Notice the formulas here. They are actually a little bit different. And hopefully you find them to be familiar. These are Pythagorean theorem, and if you really want to get into why this works, we can talk about that at a later time. But it is important to understand how to find the different components depending on what you're given, just like we saw with ellipses. You should also recognize that the equation for hyperbola looks a lot like the equation for an ellipse, with the exception. Hyperbola, you've got a minus sign, whereas ellipse, you've got a plus sign. That's really going to be your largest difference. Alright, so let's try a problem. We need to find the foci and the asymptotes of the hyperbola that's given. It might look familiar because we did something pretty similar in the last section with ellipses, but here I need to get x's and y's together and have constants on the other side. So I have 16x squared minus 9y squared is equal to 144. And then again, just like with ellipses, I need the right-hand side to be 1, so I have to divide everything by 144. And that gives me x squared over 9 minus y squared over 16 equal to 1. I know this is a hyperbola because of this minus sign. So now I need the foci and the asymptotes. In this case, to find the foci, I use Pythagorean theorem. So c squared is equal to a squared plus b squared. Not square root, plus or minus 5. So let's take a look at what this might look like graphically. Because my x value is positive, my foci are horizontal, which means that the two foci are going to be like here and here. Don't really know where they are. And it'll look something like this. So then, I just need to figure out what this c term is first of all, and I have to go from the center over 5 units in each direction. So my foci is -5, 0, and 5, 0. Now I need the asymptotes. The asymptotes are going to be these lines, here and here. They'll intersect at the origin, and despite my terrible picture right here, the hyperbola actually never touches them. And to write the equation of the asymptotes, actually not too difficult. The way that I think about it is what's going on under y, what's going on under x. So for the asymptotes, you always going to have y equals because it's a line. Here, I'm going to take what's under y and take the square root of it, so that's 4 over 3 times x, and also negative 4 over 3 times x. So you just take the positive and the negative. And this works whether or not your hyperbolas are sideways or if they're up and down. Let's find the next one. So first thing we're going to do is bring that 9x squared over. So we have y squared minus 9x squared equals 9. Divide by 9. Y squared over 9 is equal to, that's not right, minus x squared over 1 equals 1. I know that that 1 isn't necessary, but it just sort of helps see what's going on. To find the foci, I need to find that c value. And I know that c squared is equal to a squared plus b squared. So c squared is equal to 9 plus 1, which means that c squared is 10, so c is plus or minus the square root of 10. If I do a quick sketch, the x value is negative, the y is positive, which means that this hyperbola is going to look something like this. And my foci will be here, and they will be square root of 10 units away. So the foci are at 0, square root of 10, and 0, negative square root of 10. Then, for the equations of my asymptotes will look something like this. They'll both be y equals, you take what's underneath y, square root of that, so that's 3 over what's underneath x, 1 times x, and the negative. So it's okay with me if you write these equations, and you should, as 3x and negative 3x. Now we have a problem where they're giving us foci, and they're giving us the difference of focal radii, and we have to write the equation. So remember that the information from the foci, that gives us our c value, and so c in this case is 3. The difference of focal radii is 2, so that actually gives us our a value. Remember that 2a is equal to the difference of focal radii, in this case 2. So a is 1. Now we can find b. So now I have b. It's plus or minus 2 root 2. Now, again, this is something where you have to visualize it. Sketch yourself a quick graph. Plot those 2 points, 0, 3, 0, negative 3. That's going to tell me that the y values have to come first. So that when I write this, y is coming first. In hyperbolas, a is always the first one. So I'll have y squared over 1 minus x squared over b squared is 8 equal to 1. Okay, last problem. We are given asymptotes and foci. So with asymptotes, you're never really sure if you're looking at b over a or a over b. But again, with those foci, we actually do have an idea of what's going on, right? So I've got 0, 3 and 0, negative 3. That tells me that y comes first. And what is underneath y in this equation, so it'll be y squared over a squared minus x squared over b squared equals 1. So I would do square root of A over square root of B. That tells me that A is square root of 5 and B is 2. So now I can write the equation of this hyperbola. I've got y squared over 5 minus x squared over 4 equals 1.